Hey everyone, we're going to see how to scan for iBeacons using a Raspberry Pi Zero W and the Go programming language. So if you're not familiar, the Raspberry Pi Zero W is the Pi Zero that contains Bluetooth as well as Wi-Fi. This tutorial can easily be taken to the standard Raspberry Pi, but you know what? It has to have Bluetooth. So the basic Raspberry Pi Zero likely won't work for this tutorial. We will be using the Go programming language, like I said. We'll be developing our Go application on my host computer, which is my Mac. We'll be cross-compiling it, and we will be transferring it to the Raspberry Pi through SCP, which is through SSH. So I do have my terminal up. This is my Raspberry Pi terminal. I'm going to go ahead and create a new tab, and we're going to navigate into our Go path. So this is my Go path, github.com/nraboy, and we're going to go ahead and create a new project. Remember, just use your Go path. It probably won't match mine, but let's go ahead and call this Beacon project. I'm going to navigate into it. So within the Beacon project, go ahead and create a file called main.go, or it could be called whatever you really want, but in our example, all of our code will end up in the main.go file. Now, before we actually open up this file and start coding, we do need to download a dependency. This dependency will allow us to scan for Bluetooth advertisements. This is not limited to iBeacons, so we will have to do some parsing to make sure that we're getting only iBeacon data, because this will actually give us all BLE, Bluetooth Low Energy scans. So let's go ahead and say go get github.com/PayPal/GAT. So after that's done, we can start developing our project. So let's go ahead and say Atom dot. So if you're using Atom like me, this will open up our project in Atom. You can use whatever editor you want. I do have a lot of plugins installed for Atom, so when I save or even enter some commands, it'll do some stuff like type ahead, or it'll auto import our libraries for us. Again, this is all from my editor. You may have to type this stuff in manually on your editor. So I do have the project open. We can start by saying, let me add focus here, package main, and we can say function main. So we'll start with that. The first thing that we want to do is we probably want to fix up our usage of GAT. So we're going to first scan for just generic Bluetooth advertisements, and then we're going to worry about parsing those advertisements. So what we want to do is we want to say inside of our main function, we can say device, and we'll catch if there's an error, but we'll say get.new device, and for options we'll use the default. So option.default client options and we'll save it. You'll notice that it did import two headers for me here. This is from my editor. Just go ahead and type those in manually if it didn't do it for you. So if there was an error, so if error is not equal to nil, we can log that some kind of event had happened. So we'll say fatal F, and we'll say failed to open device. And we'll describe the error, and we'll add a new line. So if there was an error, we'll just print it out. Possible reasons for this would be maybe you don't have permission to use the Bluetooth device. Maybe there is no Bluetooth device on your unit, and by unit I mean Raspberry Pi. Any number of reasons could cause this error, which would cause it to fail to open. If it succeeds, we can say device dot handle, and we can say GAT, and this is where we actually have our callback type function. So this is where if we discover a peripheral or some kind of advertisement, we want this function to be called. And we don't actually have this function yet, but let's go ahead and type it out, and then we'll declare this function next. So we'll say peripheral discovered. And as far as a function goes, let me clean this up. Sometimes autocomplete isn't as good as it could be, but we'll say on peripheral and my spelling is so bad, so it could error out because I misspelled something, but we'll get to the bottom of it. That's the function that we wish to call, which we're going to create in just a moment. So let's go ahead and create it. We'll say function on peripheral discovered. All right, looks like it matched. As far as parameters go, we have the peripheral, so gat.peripheral. We have the advertisement, so that's gat.advertisement. And then we have the RSSI value, which would be the distance from the peripheral to our scanning device. And that's going to be an int value. We'll leave it blank for now. So the handle function, it's good now. The next thing is we need to create another callback kind of function for when the Bluetooth state changes. So this is useful when it actually comes down to actually starting to scan. So let's go ahead and create that. And inside that, we'll say function on state changed device gat.device and then s gat.state. Now let's go ahead and create that similar to what we did for device.handle. So we'll say device.init on state changed. And again, it gave us more information than it needed. And then we'll say select, and then we'll just leave it as empty select bracket, so that way the application doesn't immediately exit after we run it. It'll stay open until we force close it. So we have that information added. Let's go ahead and start by populating this on state changed. So what we're going to do is when the state is in the powered on state, that's when we want to start scanning. Otherwise, we're going to stop scanning. So let's go ahead and check it out. So we'll say switch S for state. In the event that gat.state powered on, then we're going to do something. Otherwise, the default is going to be device.stop. Stop scanning. So in the event that it is powered on, we're going to say device.scan. And we're going to say gat.uuid true. So what we're saying is we're going to scan for all UUIDs. We're not going to discriminate here. We're just going to scan for everything. Now, if you wanted to, you could be specific and say scan for only the UUIDs of my known devices, something that you enter. So maybe you've got 5 beacons. Maybe you want to enter their UUIDs here, so that way other radio frequencies don't pick up here as far as Bluetooth. That's totally up to you. What I am going to do is I'm going to say return at that point to return out of this case statement. All right, now that we have a functional powered on state, what we can do is we could figure out what's going to happen when we detect an advertisement. So inside of the on peripheral discovered, we're going to say, let's go ahead and say FMT print line, and let's go ahead and say string a dot manufacture data. And we'll just figure out what that is. It may not be useful to us, but you know what? That's the point that we're trying to prove here, is that, you know what, we really need to parse this data into something that we can understand. So what we're going to do before we proceed to adding more code is we're going to cross-compile this and add it to our Raspberry Pi, and we're going to run it and see what happens. So I am on my Mac still. What I'm going to do is I'm going to cross-compile. I'm going to say env. The Go operating system is going to be Linux. And then the architecture is going to be ARM. And we're going to say the Go ARM version is going to be 5. And we're going to say Go build. So what that did is it created a binary called Beacon project. But you know what? It's cross-compiled. It's meant for our Raspberry Pi, not our Mac. So it will not run on our Mac. So we can actually SCP that over. So Beacon project. That's going to be pi at, for my case, Raspberry Pi.local, and we're going to copy it to our local path there. I'm going to say Raspberry as the password because I'm just using the defaults. If I go to my Raspberry Pi terminal and I say ls, Beacon project is there and ready to go. But before we can actually do that, we have to make sure that it's not going to conflict with any other operating system level Bluetooth stuff. So we need to make sure that we shut everything down as far as the Linux Bluetooth. We want this particular application to take over. So we're going to say sudo HCI config HCI 0 down, and then we're going to say sudo service Bluetooth stop. Now, if you're not familiar with the HCI config in Bluetooth, you do have to have this previously installed on your Raspberry Pi before you try to use this Go application. So these can be obtained through apt-get, but you will need to have a properly configured Raspberry Pi unit for Bluetooth stuff before you actually try this. So with that good to go, what we can do is we can try to run it. Let's go ahead and say sudo, and then we called it beacon project, and run it. So you'll see that it's found data. It's found stuff. These are Bluetooth packets floating around my office. Not particularly useful information to us because it could be anything. Some of this stuff is probably my mouse and keyboard. So we need to parse it out and print out only iBeacon. So let's go ahead and stop it. We'll go back into our code on our Mac or host computer, and we're going to add some parsing functions. So let's go ahead and start with a structure, our structure which is going to hold the Bluetooth information, something that you would typically expect. So we'll say type, we'll say iBeacon, we'll say struct, UUID is string. We also expect a major, which is a uint16, and a minor, which is a uint16 as well. So this is typical information when it comes to configuring an iBeacon. Now that we have that information added, let's go ahead and add our parsing function. So let's go ahead and say function new iBeacon, and this could be whatever you want to call it. We're going to pass in data, which is more specifically the manufacturer data. This is going to be a slice of byte. And as far as a response, we're going to be returning an iBeacon or an error. All right, so let's go ahead and make this possible. The first thing that we want to do is when we pass in the manufacturer data, we want to make sure that it's an iBeacon. And we can figure that out by first, is the data of length 25? And does it match a certain hexadecimal value? So let's go ahead and check that out. So if len data less than 25 or binary dot big endian dot uint 32 data not equal to, and then this is a value for iBeacon, so 0x 4c 000-215. So if either of those are true, then there's an error. Let's go ahead and say return nil, because the iBeacon doesn't exist at this point, and return errors.new, not an iBeacon. Now there are different types of beacons. There's Eddystone beacons as well. We're looking for only iBeacons. If we get past this point, now we can actually do further parsing. So let's go ahead and say beacon equals new iBeacon. We're going to say beacon.uuid, and this is where the parsing comes in, equals strings dot to upper. We're going to say hex, so this is a hexadecimal, what we're going to do. So hex dot encode to string, and we're going to pick and choose what bytes we want to include in our conversion here. So when it comes to Bluetooth iBeacons, there are certain byte placements that we're after, and you can read about this online as well. But we want data. We want the 4th position to the 8th position. And we're going to do the same strategy a few times here. Plus, hyphen, because it's usually hyphenated in sections here. Plus, hex.encode to string data 8 to 10, and it's not in a string, 8 to 10 plus hex.encode to string, and then we want data 10 to 12 plus hex encode, and you'll see this will all make sense when we finish this. But hex dot encode to string data 12 to 14 plus, this should be the last one, hex dot encode to string data 14 to 20. So this is all just for our UUID. So this is typically, you set this when you configure your iBeacon. We've taken parts of our manufacturer data and we've formatted it in such that we can use it in our response. So now that we have the UUID, we can focus on the major and the minor. So let's focus on the major first. So beacon.major equals binary dot big endian dot uint 16, and we're saying we want to convert it from a byte, so a byte slice. So we're going to say data 20 to 22, and then beacon dot minor equals binary dot big endian dot uint 16 data, and this is 22 to 24. And remember, we're expecting it to be 25 as far as our length. So let's go ahead and return beacon nil because no errors at this point. And we can actually use it now inside of our peripheral discovered. So let's comment out this manufacturer data line because that information wasn't relevant to us. So we're going to say B, otherwise error, new iBeacon. We're going to pass in a.manufacturer data. Oh, getting some extra parentheses here. If error equals nil, so if there's no error, we're going to say fmt print line UUID b.uuid, and we're going to follow the same strategy for each. So the next one will be the major, and the next one will be the minor. You can format this however you want. This is just basic formatting. And then finally, the other value of use is the RSSI value, which was passed in to this on peripheral discovered. So we'll just go ahead and print it out. All right, so let's go ahead and try to run it again now that we've parsed this information into a more desirable format. I'm going to go back into my host terminal. I'm going to build it cross-compiled. I'm going to SCP it. And now when I try to run it on the Raspberry Pi, oh, that's because I didn't use sudo. All right, so it still looks like it didn't work. It looks like maybe I didn't properly compile it. So let's go ahead and oh, no, it didn't. So it's picking up other stuff as well for some reason, which is fine. But we have our iBeacon information there. So let's see if we can take a quick look to see why this other stuff is printing out as well. So after digging around, I looked through the GAT source code to figure out where exactly this data text is coming from. So it looks like there's some hard-coded logic inside of the GAT application. I hadn't really noticed it previously when I was using this particular library. If you want to, you can easily just remove it from the GAT package. It's inside of one of the advanced files. It basically gets triggered every time something is detected that's not manufacturer data. So it's the default thing to print out. Whereas if it's some other kind of advertisement, it doesn't print out. So in this case, in the case where it actually printed out our UUID and everything that we parsed, the data wouldn't have printed out with it. So yeah, there's a lot of Bluetooth stuff in my office, and that's why we're getting so many different things on the radar. But it shouldn't stop us because it's still very valuable, and we've detected it inside of the onPeripheralDiscovered function. We've detected our beacon. We've parsed it out. In reality, you're not going to be printing it to the logs. In the event that you find manufacturer data that's legitimate, you're going to take this data, you're going to save it to a database, you're going to send out some kind of notification, you're going to do all kinds of stuff other than print it to the logs, which has other kind of verbose logging or debug information with it. So just as a recap on what we did for this particular project, we installed the GAT library for our Go, and we built an application which we cross-compiled for our Raspberry Pi. In this case, I'm using a Raspberry Pi Zero W, which has Bluetooth. The GAT library by default just spits out basically all manufacturer data. It's not something that is particularly useful, but we can take the byte information and do some data transformations in order to get a more realistic UUID major code and minor code. And it wasn't that difficult to do. Now, if you wanted to detect Eddystone beacons or something else, you would change the information here because the iBeacon information is slightly different than the Eddystone. But all in all, it worked out pretty well, and it's very fast on the Raspberry Pi.